Hello everyone, welcome to our channel Technical Academy. In this presentation we are going to study about the working of the PN junction diode under the reverse biased condition. In the previous lecture we have seen forward biased condition, so we will continue to study about the reverse biased condition in this lecture. So let us start our presentation. So in case of reverse biased PN junction diode, the negative terminal of the battery is going to be connected to the P type, that is anode, and the positive terminal of the battery is connected to the N type, that is cathode, as you can see in the given figure. So now let us compare with the figure. So this is our reverse biased PN junction diode. This is our anode, this is our cathode, and this is negative potential. Here you can see the negative potential is applied to the anode and the positive potential is applied to the cathode, that is N type. The same thing is given in the point number 1. So let us see the second point. What does it mean? In the second point, because of the reverse biasing, holes are attracted towards the P type due to the negative voltage, and the electrons are attracted towards the N type due to the positive voltage. So this is due to the attraction between the different polarity charges. So you can compare this thing. If the polarity of the charges will be same, for example this is positive, this is also positive. If the polarity of the charges are same, so there will be repulsion between them, they will move away from each other. But in case of if the charge polarities are, this is negative, this is positive, if the polarity of the charges are of different nature, so there will be attraction between them, one charge will attract other. The same thing is happening in this case. So the barrier potential will also be higher in case of the reverse biasing. As we will see this thing in the equation, we will compare this thing with the equation. As the applied voltage increases, the depletion width and the potential barrier both will increase due to the diffusion of the electron and the holes, and uncovered immobile ions will be only left, and the current due to the majority charge carrier will be equal to 0. So friends, let us compare with the figure. Suppose this is our figure for the reverse biased PN junction diode. Here what is going to happen over here? As the applied potential is going to increase, the depletion width is also going to be increase. The depletion width will be very high. This thing you can compare with the equation. This is our equation for the potential barrier. Potential barrier for the reverse biased is equals to potential barrier of unbiased diode, and this is our applied voltage. So here VD is VV is directly proportional to VD. As the VD is increasing, the reverse biasing potential will also increase. See, as the applied voltage will increase, the width of the depletion region is also going to increase. So if you will compare the depletion region of the reverse biased PN junction diode and the forward biased PN junction diode, then you will find that, let us compare them in the separate figure. This is our depletion width of the reverse PN junction diode, and this is our depletion width of the forward PN junction diode. So you can compare and you can observe that the depletion width in case of the forward biased PN junction diode is very less as compared to the reversed biased PN junction diode. And this point, what does it mean? The only current that will follow in the reverse bias is the saturation current, that is IS, due to the minority charge carrier, and there will be no change in the minority charge carrier, so the saturation current will remain as it was in the forward bias, but it is very few amount, that is in microamperes. So as we have seen and we have learned that due to the electron and hole attraction, the number of the immobile uncovered ion will be increased and the majority charge carrier will be equal to 0. So the current that will only remain in case of reverse biasing is reverse saturation current, that only depends on the thermal voltage or the temperature that we have studied in the previous lecture. So let us see with the figure. See, this is our reverse saturation current, which is opposite in the direction to the ID current. See, in case of the forward biasing, this is our ID current flowing from P to N, and the direction of the saturation current is opposite to this one. And ID is equals to minus I minority or IS. So friends, if you like this video, then you can subscribe my channel, and if you want to get the notification for the upcoming video, then you can press the bell icon. Okay, thank you.